we are going to do 4 substitution systems problems. They're going to be in increasingly different forms, starting from the most basic thing that is substitution by nature, whether you guys even realize it or not, all the way up to what it would look like to set 2 equal to each other instead of potentially graphing them so that you can see what that would look like. Rather than graphing that equation, we would do it by substitution. So I want to take you with this first one first. You see this top piece up here, this first equation in our system says y equals 5. Well, that is set up so good for us to be able to plug in because it's telling you what y is. Straight up just says, hey, y is 5. Okay, well, that's convenient because we know at the end I need a solution, just like we did before, where if I have a solution, it'll be a point. That's an x and a y. I might not have a solution at all, or they could be parallel, so they don't have a solution, or they could be the same line with infinite solutions. But this one tells me right now that y is equal to 5, so I'm going to put that in my solution. And what I'm going to do is know that with substitution, I'm going to put that anytime I see the variable y. So anytime I see the letter y, I'm going to replace it with what it tells me up at the top is what y has. So my equation is negative 4x minus whatever y is. I'm going to leave an empty parentheses here, equals negative 9. And we know that it just told us that y equals 5. So what I can do, I can simplify this and clean it up a little bit. Negative 4x, we haven't touched, we leave it alone. Remember, there's a secret little 1 hiding here in front of the parentheses after that negative. So I have negative 1 times 5 is minus 5 equals a negative 9. I want to clean this up so that I can start figuring out how much x is. So I'm going to move the 5 to the other side with addition. Negative 9 plus 5 is a negative 4. And this tells me that negative 4x's is equal to negative 4. But I want to know how much just 1 is. So I'm going to divide both sides by 4. That will cancel out over here and tell me that x is equal to 1. Perfect. That is what I needed. I could plug that back in to double check my answers. If we wanted to check our answers, all we have to do is plug in our solution into both of the equations. The top one just says y equals 5, so that's even less to have to plug in. But if we wanted to try it, just to see if it's correct, we need to see if this statement comes out true. Negative 4 times 1 is negative 4. Minus 5 equals negative 9. Is negative 4 minus 5 negative 9? Well, yeah, it is. So that means that my solutions are correct. I can add my 1 down here to this point, and my answer, or my solution to this system down here, is the 0.15. We're going to do that same thing, only we're getting a little more difficult this time. This one's y tells me that it has a variable involved. This time y is equal to 3x. So I'm going to do the same thing and just substitute or plug in, replace every time I would see a y with what it now tells me it is down here. So I originally had 2x plus y equals 10. But y secretly now is 3x. We want to clean that up. 2x plus 3x equals 10. You want to combine any like terms that you may have. 2 and 3x make 5x. And I know that 5x's is equal to 10, but I want to know how much 1x is, so I want to eliminate that variable in front. Dividing both sides by 5 tells me that x is equal to 2. I'm going to need to remember that a little bit when I do my solutions. But now knowing that x equals 2, I don't have enough to come down here and say solution is blank and blank. I don't. I have enough to say that x equals 2. I don't know y yet. But what I can do, I can take what I now know for x and plug it in to my equations up at the top to find out what y is equal to. So I can take that equation, the other one we haven't worked with yet, y equals 3x, and just replace the x with a 2. Y equals 3 times 2. Well, most of you are shouting at this video right now saying, well, I know what 3 times 2 is. It's 6. And there you go. You have a solution. If you wanted to plug those back in to make sure that they worked, you could do that. Seeing what you would have y equals 6 equals 3 times 2. 6 equals 6. Good stuff. 2 times 2 is 4 plus 6 for y equals 10. Does 6 plus 4 equal 10? Yes, it absolutely does. So that means that my solution down here is correct as well at 2, 6. Stepping it up to the final 2 notches, these two are very similar to one another, but just in case, we're going to do them anyway. You'll see same situation is happening here with our y's on this bottom equation. It tells me that y is equal to 6x plus 13. So I'm going to take that 6x plus 13 and just plug it in wherever I see a y. Same thing, it's just a little bit longer of an expression this time. So you guys are getting the drill. 4x plus 2 times whatever y is equals negative 6. And y equals this whole thing, 6x plus 13. We have to clean that up. We're going to have some distributing to do, but first we keep the 4x where it is. We haven't used it. 2 times 6x is plus 12x. 2 times 13 is plus 26 equals negative 6. I want to combine any like terms I have. I have x's over here that I can combine. So far, so good. I want to move the 26 to the other side by subtracting it from both sides, which leaves me with 16x is equal to negative 32. Remember, negative 6 minus 26 more, it's getting more negative, is a negative 32. Divide both sides by 16, and x equals negative 2. X equals negative 2. I can take, just like I did last time, and plug it back in to the equation up here this time. I'm going to plug it in. Oops, that's not a highlighter. Plug it in for x this time. So I would be starting with y equals 6 times whatever we learned that x is negative 2 plus 13. And I'm going to put that negative 2 right on in there. Y equals 6 times negative 2 is a negative 12. Plus 13, simplify any like terms that you have to clean them up. Negative 12 plus 13 is just 1, which makes my solution x is negative 2, y is 1. Negative 2, 1 is the point at which these would cross if you were to graph them. And the last one is set up exactly the same way. I just want to chat about it because it does look different. This looks like one that you think you would graph. I would, if I were you, think that I'm looking at this and going, okay, well, it's got 2 equations. They're both set up like slope-intercept form. I should graph these. And you totally could graph them. But since we're doing substitution, I want to talk about the fact that this says that y equals this. And this says y equals this. That means that both of them are equal to each other. Because if I were to take this bottom equation, y equals 8x plus 2, and plug it in highlight this one. If I were to plug this 8x plus 2 in for y, they would be set equal to one another. Because they're both equal to y, they are equal to each other. 8x plus 2 is equal to x plus 2. What that means is we just have some cleaning up to do. There's not much actually happening here as far as the x's are concerned. I want x's on one side and numbers on the other. So what I'm going to do is move this negative x to the other side now. Subtracting from both sides leaves me with 7x plus 2 on the left and just a 2 on the right. But I don't want that. I want numbers on the other side. So I'm going to move this 2 by subtracting it to undo it to the other side. 2 minus 2 is a big fat 0. And I love when I see things like this where it says negative 7x is equal to 0. Because when I divide by 7, I'm left with just straight up x equals 0. And that is so friendly to work with. This right here is like a best case scenario. X equals 0 is so good to be able to plug back in. You could plug it back into either one of the equations up at the top. I'm going to pick the top one just because I can. I know that x plus 2. Well, x is 0. What is 0 plus 2 is 2. Could do that same thing with the other one, was 8x plus 2. 8 times 0 is 0, plus 2 is 2. So that tells me that my solution here is 0, 2. It would be a y-intercept. You can see they have the same y-intercept if you look at their pictures and you look at their equations. But remember, like I said, when you see two that are set y equals some stuff and then another y equals some stuff like these, you would set them equal to each other. I'm not going to do this case, but what you would see, just to make it clear again, let's say 3/4 x plus 2, and you saw another one that said y equals 5/8 x minus 3. If you wanted to substitute these two things, you would see that they are both set equal to y. So your first step would be to substitute and set them equal to one another. We're not going to do that. I'm not going to make you work with these fractions. Just wanted to make it clear that no matter what, if you see two things like this where they're both set equal to the same variable, when you are solving them, your substitution is going to lead to you setting them equal to each other. Same thing, I just want to say in case it's x's, if it says x equals 14y, and this one might say x equals y plus 3, this is your system. If that's the case, just because they are both equal to equal to x, same thing. You'd set them equal to each other and solve from there. Just keeping that in the back of your head. Good luck on the rest of your review.